Associate at COGEN Europe, and today I will be presenting our vision for how cogeneration can contribute in a carbon-neutral energy system. So a few words about COGEN Europe. We are the cross-sectoral voice of the cogeneration industry. We work with EU institutions and stakeholders to shape better policies, promoting energy efficiency, energy systems integration, and the more focus on realizing the potential for cogeneration. Our membership, in a nutshell, we are a hybrid association with national associations from across Europe as well as the world, and corporate membership spanning across the entire energy value chain, from manufacturers of cogeneration systems from the kilowatt to the megawatt, as well as energy solution providers, energy service providers, utilities, and industrial users of CHP as well. So in a nutshell, what is cogeneration? Cogeneration uses all sources of thermal energy to produce both heat and electricity simultaneously, and this way it achieves higher efficiencies. It's actually an efficiency principle, and it can apply to various technologies from turbines to engines to fuel cells to organic Rankine cycle. And in doing so, it uses all energy sources that are available, from all gaseous fuels to geothermal to solar thermal. This includes hydrogen, also waste heat. Biomass is an important fuel to CHP. And it ensures that all these fuels are used more efficiently. So why is CHP needed? Again, a focus on efficiency. Europe's energy system is quite inefficient. If you look at the latest statistics, you see that 400 MTOEs are put into our power system, and about 215 of those are actually wasted in energy conversion as heat that is discharged into the air. Then an additional 22 MTOEs are wasted over the grids for transporting all that electricity to the end consumer over long distances. So just to put that into perspective, 230 or 240 MTOE, more than half of the energy input to power plants is wasted. Most of it is heat. And then if you look at the total heating demand of European buildings, that's only 200 MTOEs. So if we were able to recover some of that heat and put it to use, we would already solve part of our problem with decarbonizing heating and cooling in buildings. And that's where CHP comes into play. With CHP, we produce electricity and heat at the same time, and so we reduce conversion losses quite significantly, as well as reducing grid losses. So zooming out to the overall energy system, CHP has a role to play in the increasingly integrated energy system of the future. CHP, while using all these available energy sources more efficiently, it also generates electricity where and when needed, as well as efficient heat for various consumers. And that includes district heating, it includes higher temperature heat and process heat for industry, as well as on-site generation of electricity and heat for buildings. So we see that the consumers and energy consumers must be at the center, and all of these different consumers use cogeneration from buildings, from hospitals to districts to industry, as well as some iconic buildings. And in fact, cogeneration is at the heart of Europe because all EU institutions have buildings that use cogeneration. So the Berlaymont building, the Justus Lipsius building, and also the European Parliament building in Brussels, all rely on cogeneration to decrease their emissions, decrease their energy costs, and also improve their efficiency. So what is our vision for 2050? We have committed, and all our members have committed, to a resilient, decentralized, and carbon neutral European energy system where cogeneration can contribute in a significant way by 2050. So we have committed to a net zero energy system. And to flesh that out and to quantify that contribution that CHP can be making, not only today, but towards 2050 as well. We have commissioned a study that was carried out by Artelis, which is a Europe-wide modeling company that has an integrated gas, heat, and power model. To actually quantify the potential of CHP for 2050 in a net zero energy system. I will show you the high-level results of the study. Also, I'm showcasing who has supported the study. So again, this shows that CHP is a solution of choice for a number of energy stakeholders and has the industry support from manufacturers, utilities, industrial players, and energy service companies as well. So in terms of assumptions for the study, what we see in the Commission's long-term decarbonization strategy is that what will happen until 2050 is that electricity capacity will increase, and also what we see is that we'll have a reduction of energy consumption, with some of that demand being electrified, which you can see here on the right-hand side. However, even when we reduce demand quite a lot and we electrify some of that demand, thermal energy will still be needed to support system resiliency and support system efficiency. So we see that these fuels that would need to be used in the energy system have the potential of being used efficiently with CHP. Here you see the study assumptions for heat generation in buildings. There's about 825 terawatt hours of fuels like hydrogen, e-gases, biogas that will be used in buildings. And the most efficient way to use that is with cogeneration. It's the same with industry. To deliver high temperature heat, gases and biomass or bioenergy will need to be also used for industry to supply that medium to high temperature heat in a cost-effective way. So what was the modeling approach that was taken for CHP? So for instance, for heat, we're looking at maximizing the use of CHP throughout the year. This is the CHP hourly operation in red, and then the use of peaking boilers is employed at times of peak demand. Same with the electricity system. In 2050, we expect that a lot of the demand will be electrified. So for the heat that will be electrified, that will lead to a very high peak demand in winter compared to summer. And that will be covered to some extent, to a large extent, by intermittent renewables like wind, PV, maybe base load as well. And then the role of CHP will be actually quite important of covering that residual demand at times when renewable electricity will not be sufficient to cover peak demand. So you can see here in orange how CHP will be contributing towards a more resilient and secure energy system. There will also be a role for CHP to contribute during summer, even though that role will be slimmer. But it's really important to know that CHP has this ability of ramping up and down depending on the availability, depending on the demand and the availability of renewable electricity. So these are the results of the study. When we do optimize the operation and the deployment of CHP to deliver more efficiency and more flexibility to the overall energy system, we get quite high benefits and important benefits in terms of a reduced cost of the overall energy system between 4 to 8 billion euro annually. This is because of the high energy savings that are delivered through CHP, up to 220 terawatt hours. This is about 2.5 times the amount of electricity that is consumed in Belgium, for instance. Then there's also still a contribution towards reducing remaining CO2 emissions in a net zero energy system. And then in terms of contribution to electricity and heat supply, CHP would deliver up to 16% of electricity production and up to a third of total heat supply in Europe. There's also important benefits for CHP users, and you can see here that CHP can contribute towards reducing the costs in various users. In an industrial site, for instance, you can have between 3 to 10 million euro that can be saved by adding CHP to the mix of solutions that will deliver energy to that industrial site. So that's quite important, and it's a very salient result and relevant result in the current energy price crisis that we have. So also, what is the contribution of CHP for key sectors? For instance, in buildings, CHP can deliver about a fourth of the heat demand. In industry and SMEs, the same, 26% of the total heat demand, as well as in district heating, where CHP is an important solution and can contribute up to 40% of the total heat and almost 100% of the heat that cannot be electrified. Again, a repetition of the key benefits of CHP based on the study that was carried out. So in a net zero emissions energy system, we have identified CHP as a solution that is enabling more efficient, cost-effective, and resilient energy system. It is a future-proof solution because it can use various fuels and it can increasingly use renewable and decarbonized fuels. And its key benefits stand in terms of primary energy savings, reducing emissions towards 2050, as well as saving the energy system and consumers quite a lot of money. So our call to action and the main policy ask there is to prioritize cogeneration for all thermally generated heat and power, which will inevitably avoid wasting valuable energy. So with that, I'm happy to get any questions, and the result, I invite you to actually look at the detailed results of the study. Thank you, Alexandra.
can return into, like, stop the screen share to take. If you want to have a look. Can you see the chat, Alexandra? Can you see it? Maybe you need to, if you, there's this side, it has to be in green. There's like
Live discussion.
yes.
I see. What is the impact of including scope 3 emissions of cogeneration plants? Indeed, so I would have to look into the assumptions that are used by Artelis in the study. I think they've used a broad scope for emissions. And well, the more you use CHP, the more you reduce all greenhouse gas emissions. So that would be my simple response to this question. And then I'm wondering if there's additional question. That was the only question, but maybe there are more coming up.
Also for the participant, if you want, you can basically ask to go on stage and ask your question to Alexandra as well. Like, you want maybe Alexandra to give some closing remarks, and so I can stop recording, and then we still have 10 minutes left. But so if there's any more questions, people can ask, but so just be aware of the time.
Yeah, indeed. So just to close, I think we see that Europe has committed to this quite ambitious objective of becoming the first carbon neutral continent. In order to achieve that in a cost-effective way, it is really important to have the whole range of energy solutions that contributes. And for CHP, we think that it is one of that solutions that can both complement higher rates of electrification, which are definitely recognized as decarbonizing solutions, and it can also contribute towards higher shares of renewable energy uptake, both when it comes to thermal renewables like biomass, biogas, hydrogen, waste heat, by using those renewables more efficiently, but also by ensuring that intermittent renewables like wind and solar are well complemented by the appropriate and most efficient backup. So I think that at least COGEN Euro membership sees the energy transition and the objective for net zero emissions as an opportunity to actually contribute and deliver cost-effective transition towards 2050. And with that, I'd like to very much thank the audience, and I'm happy to answer any questions offline as well.